Don't wish to live to 102. Okay, you can live to 102, but it's not all that's cracked up to be. Okay, so we want to continue on in chapter 15, and there's a lot in this chapter. If you've not looked through this chapter, this is one of the chapters that you could have a whole book on or a whole course on just this chapter. And I was reminded at a show that I was at that this is one of the chapters that you can not only get a job on, but you can get a job in the entertainment industry doing shows for, like, if you want to move to Las Vegas and work with the people that do the automation for the shows that they have in Las Vegas or some other place that they have shows and stuff like that, live shows. If you want to design those, basically this is the chapter that would give you the information that you would need. Although I basically talk about only from a process point of view and in a factory, but the same equipment, the same automation concepts are used in writing the programs for various entertainers and all that kind of stuff. So you can kind of take this same information and make it a career that would work in the entertainment industry as well as in manufacturing. So we talked about this a little bit, and we talked about situation awareness. And this is about where we stopped. So here is a process like you would show on the screen if you were following if you were following the people that wrote the book about high performance HMI, you would find that this would be what they would recommend. But this is what most people are expecting. So how would you get from here to here? Okay, well, you would have if you wanted to, if this is a PID block and you wanted to show this, what you would have would be an invisible button. So you program an invisible button around this. And then when you hover over this with your mouse, you'd click on it and this would be a pop-up. So that's how that's done. It's nothing, this is not rocket science. They do have invisible buttons, and you can make an invisible button do anything you want to, and this is one of the things you can make it do. So click on this area, and then this would appear, and then over to the side you'd be able to address the issue. So that's how that's done. So these are pictures here of some of the things that were in that white paper from Bill Hollifield. So I cannot do his verbiage, but you can, in all honesty, take a picture from one of his books or one of his papers and stuff like that, and you can show the pictures, and this is what I did. And I don't comment on these a lot, but this does show you some of his ideas. And tables can be useful. And this is a table, okay? Large amounts of data. In other words, you want to portray something that gives a lot of information to people without scaring them. You want them to have all the information that they need to know in order to make good decisions. And so you're trying to get them, you're trying to teach them, okay? So that's the whole idea of this idea, is to teach them, okay? And this would be a good example of alarms. Don't spend don't go overboard with alarms, but if you do have them, you can make different colors and that type of thing. But make sure that you don't have 20 alarms blinking on the screen at one time. It does not work. And this is a way of linking an area to alarms. This, in other words, if there was an alarm, then this would be the pop-up for that alarm. So you click on it, and this would be the pop-up. In other words, you have an alarm, click on it, the invisible button, and then the invisible man, and then you click on it, and this will tell you what to fix, how to fix it. So that's the best approach for that. Okay? Here is a idea for running, okay? Now, he's saying that it is wrong to use red for running and green for not running, okay? He's saying it is better to run colors of gray. Stop would be a dark color, and then white would be a running color. That's your choice. I mean, somebody can tell you, by the way, if you're doing this sort of thing and people tell you what colors to use, what's your answer? Okay, you're paying. So basically that's what you do. But on the other hand, if nobody's going to tell you what to do, he's saying that this is better. And you don't stand there and argue with them and say, this is the standard, this is what we're going to stick to, and you can't make me change. No, you do what they tell you to do. But most of the time, this is the best way to go, okay? So here's another one. Use bar graphs that go across as opposed to this. Which way would you rather see the answers? Would you rather see it like this or like this? Like this. Because why? You at least see it's a percentage of full on. These you question, what is full on? What is the full, what is 100%? So again, make it a moving bar instead of a bar graph. That way you can show a percentage of full on. It gives you a better perception. Here's another one. Now I'm going through some vignettes that I can ask you to sort and sift. And again, I have asked these in the past as far as questions are concerned. I don't know, but I have asked this before. Sort these from worst to best. Now, this is his opinion. He's saying that 3D is not as good as 2D. Okay? Why? Because it detracts. Now, you can decide whether you like that idea or not. Why is this better than this? Because there's more information. Why is this better than this? Because there's a histogram in there as well. Now, what is this better than this? Well, because there's a histogram and showing you where you're out of limits. Okay, so this is the best, this is the second best, the third best, the fourth best, the fifth best. Or you may choose to build everything because somebody told you they like 3D and they're willing to pay you good money. Go for it. But if you have a chance, do this. This is much better. And I believe them. I like this much better than I do any of these others. This is not bad. Now, why are histograms so good? Because they're like an oscilloscope. They open up what has been going on and how long, and you can stretch this or make this smaller or whatever. So historical data plots are very, very, very useful, and you should use them, and you should have them in a lot of your screens, and you should bury them in these kinds of things like this. Okay, here is another one showing valves. So these are pictures of how to do things. So a cluster of valves, you can show their state and show which ones have to be on for certain things to happen. And these are examples of that. I honestly think this is almost like gold. If you look at these, you should look at these very hard because these are very good. Now, what's the rub in PLC programming? If you make a change, what do you have to change in a PLC program? You have to change the logic, right? And you have to verify. If you're in a plant and they come up with a change, you have to change the logic and you have to what? You have to verify that it works, right? What else must you do? You must change the HMI. And again, you must verify it. What else must you do? You must change the diagnostics program. And what else must you must verify that. There's 3 areas that you must change every time you make a logic change. The logic, the HMI, and the diagnostics. And if you forget these other 2, or one of these other 2, what happens? Something bad can happen, and you have to remember that these are all linked. So what would be the nicest thing in the world if these were all linked, right? But is it by nature in a PLC that way? No. There are some people that have come up with plans of how to do that, but again, it's rare that you can do that. So you have to remember basically that every time you make a change, you must make those other two. This is not rocket science. This is just how you must make these changes, but you must do that. And you must verify all three of them. In other words, you must make it go out of range and see if it does change and all that kind of stuff. See if the lights change or whatever. What are these? Trends, okay? Trends should be embedded in the graphics and appear showing proper history whenever the graphic is called up. All right? It is possible but not generally utilized. Trends should incorporate elements that depict both the normal and abnormal ranges for the trended value. This is very important. Trend graphs are very, 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 very important. And again, this is another area that what are you trying to do? Teach people. You're making checklists. Okay? You do this, 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 you do this. Did I do it? 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 Etc. You have to check out. If you have things like that, the best place to put them is on the screen of the HMI. You can put it in a book, you can put it in a manual, but they won't check it. They will check this. You can also have shut down and start up procedures, and you can have those on the screen. And I want to show you this down here. Now, this is something that, this is startup procedures, but I want to show you this right here. Now, what is this? Bless you. What is this? A PID runs best at 50 to 80%. It doesn't run well, as I say, down in the weeds, down in this area right here. So what must you do in many cases? In order to start up a system, what must you do? You must run it in manual until you get up to a certain area, until you get up into this area, and then it'll flip over to automatic. Does everybody follow that? Because when you're running down in this area right here, as they say, you're down in the weeds. You're down in the area that it does, your PID algorithms might go unstable on you, and they may, if it was a flame, it might turn off. If you've ever tried to start a furnace and you light a match and you get it started and then it turns off, and you do that about half a dozen times, and then finally you get it to the point where it gets heated enough that the thermocouple will actually take off and run for you. That's what this is about. So if you want to start something and then it actually climbs up and then starts up instead of turning off about half a dozen times, you need to run it in manual. You need to grab hold of whatever it is that you have to do and run it in manual until you get up to a point where it'll take off and run in automatic for you, which is up in here. So how do you do that? You play bumper pull. You actually show the limits of what it is you're trying to do, and then you show if it's out of those limits. And if you're like, I've got to run, this is me getting out of the harbor. I have to go down this little narrow pathway in order to get out from where I'm anchored in, zero, and I come up here and I go this way and I go that way, but I have to get along in this little area until I get up in here, and then I can run it okay. If you don't think this is valuable, this is very, 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 very valuable to show you where you're at and how to run in a confined area. So you're sitting there with your hand on the pot, turning this valve to stay in this arena until you get up to this area. And then when you get up in this area, it can automatically switch over, or you can, by observation, say, now I'm ready, and you flip the button and it goes to automatic and you're off and running. This is how you heat up an oven at 5 o'clock in the morning on a Monday morning. If you've been down for the weekend, you start it up, you come in, somebody comes in at 5 o'clock, they run this little puppy like this, and they run this one like this, and they run this like this, and it runs, and it takes off and runs. But you don't want to have to be at 5 o'clock in the morning making that happen. You want to have an operator that's sitting there doing this and following your direction. That's what you want. You do not want to do this every Monday at 5 o'clock. Believe me. Any questions about any of this stuff? Now, this is a picture of levels. People refer to levels of control. So this would be the main big plant. This would be an overview. Now, this is where you have to show the plant overview to the higher ups when they come through. But most of the work that you're doing is down in these levels right here, okay? Now, this is a definition, and I honestly, they've got sublevels and all that kind of stuff. I'm level 2A or level 2B or whatever. I don't care. I'm serious. I don't care. And I'm not going to ask you a question about it, but if people refer to levels of control, this is what they're referring to. All right? People get all upset about level of control. It really doesn't mean that much. It means basically that this is the overview. This is what you want to have that looks really good for the people that are, this is where you may want to do a little bit of animation, you know, like the guy running across the screen or something like that. And have a little bit of joke about it for the people that come in from outside. But this is where most of the work is done, and this is where most of the operators are going to be looking at. They're not going to be looking at this that much, I don't believe. So here is some of the level 1 operation. And again, they don't mince words. They do not have P and IDs anywhere. They don't have any of that stuff anywhere. They're adamant. This is some of the level 2 unit controls and some of the level 3 unit detail. I could care less, except for the fact that these are definitions that you could say, okay, now I can understand for my application what level 1, level 2, and level 3 is. And this is a very sophisticated operation. Obviously, I don't know what it is. I don't know where they're coming from, but this is a definition of level 1, level 2, and level 3 control. I'm not going to get upset about it. I'm not going to ask it as a test question. But if you get involved with people that say, now, are you doing level 1 or level 2? You'll say, yes. You do what you have to do. But most of the time, I don't see a lot of splitting levels into level 1, level 2, and level 3, except for the fact that some people like this. And again, not last summer, but the summer before last, got really up on videos from third-party sources. And I noticed that RealPars, which is this company right here, they're Brits. They're very, 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 very British, but they're very good. And they charge for some of their videos, and some of their videos are free. And so they have schools, they have all kinds of stuff, but they got onto they got onto HP, HMI, high performance HMI, Bill Holofield and all those guys, and they really liked their stuff, so they made some really nice videos of their stuff. So these are some of the videos from RealPars of Bill Holofield's HMI stuff. So if you don't like what I've told you, you can read the same thing or do the same thing by looking at RealPars, or you can go deeper with RealPars if you want to. But there's some of the stuff that you can look at, and there's other people's as well. Okay, so again, all great people think the same way, right? I'm just kidding. I'm just a little guy over here in the corner, but I noticed that RealPars did the same thing, except they probably didn't get a call from Bill Holofield that told them they couldn't put the stuff in their videos. He said, go ahead, you know. But anyway, now what is OPC? OLE for process control. What is OLE? Object linking and embedding. So this is an acronym of an acronym. OLE is Object Linking Embedding for Process Control, OPC. Okay, and then they also have OPC, what? OPC UA. What started out as simple OLE became OPC, which became OPC UA. So what is this? Well, this is a way to link objects and variables between a PLC and a computer. In other words, if I want to use a computer with Visual Basic or Visual C Sharp, C Sharp, yeah, Visual C Sharp, I can write the programs and make the information in VB, and I can use OPC UA to link those variables to variables in the program controller. All right? Sometimes this is a cost, this is a one-time charge. Sometimes it's a one-time charge plus other things, but it can be very useful. And if you want to, as they say, write your own or roll your own, this is one way of doing it. Now, this is a one-time charge as opposed to a charge by application, but you can decide how you want to do this. And some of you are going to say, I don't want any of those other packages. I don't want WinCC. I don't want the Allen Bradley project. I don't want Ignition. I want to do it myself. I want to do everything myself. What's the back side of that? You'll be spending a lot of time doing it right. You'll be spending a lot more time doing it than if you would just use a package to help do it, okay? Sometimes you get some graphics with it, sometimes you don't. You say, well, I can make my own graphics. Yes, you can. This takes time. You can buy packages of graphics, you can buy static things, you can buy active things, you can do all kinds of stuff. And you can buy figures, you can buy different symbols and stuff like that. Or you can make them yourself. So which way are you going to go? Are you going to pay the big bucks to buy a package from Allen Bradley or Siemens or this new one, Ignition? Or are you going to roll your own and do it yourself? It's a choice you have to make. But you cannot say anymore that you don't know that it exists, because it does. Okay? The other question is, has the professor ever written an OPC program? And the answer is yes. I wrote it a long time ago, 30 years ago. And at the time, the Windows that we used was Windows 95. Windows 95 had a very big flaw in it. The flaw was every time you closed a window, that area in memory that window took up was now frozen, and you just kept building. You kept inching in on the high end of the memory until you used up all your memory. And at the end of the day, or at the end of 2 or 3 days, what happened? You ran out of memory, and it would burp on your program and it wouldn't run it. So what do you have to do every couple, 3 days? Close it down and start it up again, and then you'd start off with a new set of memory locations. That was not good, and I didn't know that. I walked right into it. But it worked okay, and they used it for a while, and I don't know what ever happened to that application. They closed that plant down eventually, and I don't know. But I think that was a good place for me to learn it, and I appreciate them giving me the opportunity. That was the Andersons down in Bowling Green, by the way, and I did make it so that it was okay. I linked an Excel spreadsheet to Visual Basic to the program in the PLC, and that's what I did. Didn't have a lot of graphics, that's okay, they didn't need it. And here you go, you can understand the ABCs of OPC UA and everything you need to understand. OPC UA applications in the pharmaceutical industry, OPC applications in the food and beverage industry, OPC in the automotive industry. There they are. Okay. This is the bottom line in most applications. You must have a graphic that does the following. You can turn it on and off. You can turn a machine on and off from the HMI. You can turn it on and off from the HMI, and you can turn it off from the program. And you view the status on the HMI. We talked about this the other night, but we didn't really show you this picture. But this is your ultimate goal to be able to do. However you do that, it's up to you. And put it all in one button if you can. Which gets you down to the next question is where to put the logic. Okay, this is more of a philosophical question than anything else. Where do you put your logic at? Do you put it in the PLC or do you put it in the HMI? Good question. My general philosophy on this is this. If it's going to be something for control of the process, it should be in the PLC. If it's something that does not affect the actual control of the process, but it might be something that change the values that doesn't control the process, doesn't affect the absolute running of the process. You can put it in the HMI or you can put it in the PLC. Large amounts of data you should put in the HMI or the higher level computer for sure. Any questions about that? This is an example of putting this, you remember this application, right? This is the one application we talked about in chapter 8. Now, if you want to automate this and turn these lights on, you can do that through the application in the HMI, because what you can do is you can say the color of this light changes with certain conditions. In other words, at a certain point, when your counter gets to a certain point, you can change the color of this light. And you can actually put that in the PLC you can put it in the HMI. You can actually make the logic in the HMI to turn on and off to change the color based on a certain count in the counter. You can do that. And here's how it's done. Tag greater than 20. Tag greater than 10. Tag greater than 0. True. Else it's false. There you go. Does everybody see that? You can write the logic in the HMI to change colors of tags based on counts and stuff like that. And there's nothing wrong with that. It's just, where is it? If it starts changing color and you forget where it's at, you're going to say, well, it changed it in the PLC. You might not have. All right? If you want to make somebody very uncomfortable, in other words, if you want to hide the data or hide the logic, all right, I'm going to tell you how to do this, and I want you to never do this, okay? But if you want to mess with people's minds, what you do, you put some logic in one button number 1, put some of the logic behind button number 2 on a different page, and you put some of the logic in the PLC, and they all affect each other. They will never find it. Okay? You want to play with people? This is one way to do it. You say, well, you can do searches and stuff like that. Some of this stuff you can't do searches on. You can bury it in such a way that they can't find it. All right? Does everybody follow what I just said? You can make it so hard for people to find the logic, things turning each other on or off, that they'll never get it. So again, I would never do that. I hope you don't do that. But I ran into situations where that was happening and I hated it. But I eventually, what do you do when you do that? When that happens? You take the logic in the PLC and you move it and you see what changed. You move it from one place to another place and you see what actually had changed. And that's the only way I got it. That's the only way I solved how to fix some of the logic that I was faced with. I was programming behind a guy who was, he bragged about the fact that he was a Mensa, M-E-N-S-A, which means what? I'm smart. Okay? He was. He buried the logic very effectively, and it took me a long time to get it all figured out. but the only way I did it was by moving stuff around until I saw how things worked. I got it. Anyway, I destroyed his logic in the process, but so be it. So anyway, you have a choice how you want to play the game. And you can play it a number of ways, but believe me, especially if you use OPC-UA, that's what he did. He used OPC-UA, and his buttons were in the computer side. Unbelievable. I ended up spending a weekend, and I got it, but man, oh man, did I sweat. Anyway, so this is the stories that I told you before about going from 6 screens to 66 screens. So I put that story in here, not to scare you or anybody, but to tell you that you can have big changes in the HMI, and there can be massive. But also be aware of the fact that anytime you put a button on a screen, it must have a reason, and not upset the process. You have to ask those questions. Is this going to upset the process if I do this, if I add this button? If I give the operator this piece of equipment, this power, is it going to create more havoc than it is good? Okay? Now, you don't always know. So it is better to create the logic and then take it away what operators can use to mess things up. What I mean by that is if you are creating a system that has an auto and a manual, and they're in manual and they're messing things up, what do? You don't take the logic out, just take away the fact that they have an auto manual button. And you basically eliminated the need for you to have to go between auto and manual. You stick it in auto and keep it that way, and they can't change it to manual because they don't have access through a button. But you've got it there if they ever come back and need it. It's better to have it in the logic and then take it away, and only thing you have to do is to just take the button off the screen. It's a 5-minute fix. If they're using something bad in a bad way, just take it off the screen. So it's better to create the logic, verify the logic, and then take it away than it is on the screen than it is to not have the logic written at all. Because if that's the case, they're going to want it. They're going to say, well, how do you do manual? And you're going to look at them and say, I didn't create a manual. And you're going to say, well, but you have to have a manual. So now all of a sudden you're faced with the idea of how do I create a manual system on top of an automatic system that I didn't write for, I didn't plan for. And all of a sudden you're realizing that I've got 3 more weeks of work to do before I can verify my system. So write the whole thing, write it auto manual, and then back it off if it becomes an issue, as opposed to not writing it and then having to add it later. Does that make sense? It's better to back things out than it is to have to verify and put them in later after they've started the system up. It's a lot harder. Okay. And this is the one I talked about with the 4 people, and there were 2 PLCs and the guy from India and myself and all that kind of stuff. And that was good, okay? Here's another company, DMC, that has done a lot of work on trying to combine the idea of the logic, the button on the screen, and the diagnostics. And they've tried to do that with a lot of different applications. I appreciate that. I don't think it's possible in a lot of areas, but if it's possible, you should take advantage of it. If you can write one thing as opposed to three, it's much, much better. And here's another bunch of stuff. Okay. Now, we have in EET land, we have another course, and most of you not even heard of this before, but it's called SQL. Maybe you've heard of it, but you just don't know about it. Okay, SQL. So what do you do with the data once you've created this thing and you're running? Well, you dump it to a computer, which then you use SQL, MySQL or whatever, to digest and use this stuff in a meaningful way. So the other side of the rainbow is what? SQL. Okay? It's either Oracle or it's MySQL or it's one of the other database packages. So again, once you've got the data and you've dumped it back to the computer system, the only way to digest it and to do anything with it is to use SQL. And you can either take our course, EET 4250, or you can buy a book, and about 3 weeks later you can dig yourself out from under it. But basically, any of those approaches work. But you will have to learn this if you want to take that data and do anything with it. So this is where the reports are. EET students, and I'm not bragging about them, but EET students have to take 2 more courses besides everybody else. If you're sitting in this room, they have an advantage in that they take a CSET course, 2200, and they take EET 4250, or most of them do. I don't know if they all do or not, but they have to take this course. They should take this course. All right, what is this? This is a networking course. And they get it. After you've taken that course, you can put computers together on the factory floor, including the PLCs, the computers, and everything, and you can put them all together and you can make them work. What is this course? This is the SQL course. Okay? Whether you take these courses or not is up to you if you're not an EET student. If you're an EET student, you got to take them because why? Because somebody saw the need for it. Okay? Somebody expressed an interest in that these courses were important, and we went through the IAB, the Industrial Advisory Board, and they said, yeah, these are good courses to take. And then we found some good teachers to teach them, and they're excellent teachers for both of these courses. And I'm telling you that those are good courses. If you have an open, if you're not an EET student, fine. But if you have an open elective, this course is almost one of the best courses you could possibly take. The guy is good, okay? So if you have an open elective, this would be a good course to take. This would be also a good course, but like I said, with this course, you get a good book. In 3 weeks, you can probably be up to speed pretty well if you understand that this is going to take you a little bit of time. So instead of going on your vacation to the Bahamas, you basically go into hibernation for a couple, 3 weeks, and you come out the other end, and you're a SQL expert. But that's neither here nor there. But that's the other side of the coin. So logic, PLCs, you also need to program in a higher level language, which is, everybody can learn that eventually, C or some other programming language. But then ladder logic, networking of computers, and SQL. And that'll get you a job. That'll get you a good job. These are the things that will add to your ability to get that $80,000 to $100,000 job and then keep going from there. I've had people say that because of this course, they were the one of 2 or 3 people at the GM plant up on Alexis Road that got to go and start up a new project in Japan because they had computer networking experience, and none of the other engineers had that experience. So again, I'm not trying to tell you what to do, but these 2 courses they're worth their weight in gold. Anyway. Of course, after this course, which is, this is the whatever. Don't worry about me. Anyway, so these are some more. You can watch some real pars on them, and they'll tell you the same stuff, right? They'll tell you how important they are. Anyway, so that's that course. And any questions about Chapter 15? Chapter 15 is in the books. We're going backwards now to chapter 10. Chapter 10 has some things in it that I want you to understand. And not that you don't understand some of this stuff, but I think you probably don't understand some of this stuff. So this is how we skipped over some things that I think are very important, and we're going to go back and get a couple of them. Not all of them, but a couple of them. Okay, so this is chapter 10. And how to get analog data into your PLC and how to get it out of your PLC is very different between Allen Bradley and Siemens, and I want to show you how that's done. We didn't talk about this in this course. We didn't talk about this earlier because we went through too fast. We went through some of this stuff at the speed of light, and I want you to understand that some of this stuff actually is of value. All right, so this is where it's at in this chapter. All right, how do you get analog information in and out? They're very different between Allen Bradley and Siemens on this one issue, and it's very, 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 very different approaches, okay? So with Allen Bradley, I'll show you in a minute, but this is the Siemens approach. Use these two instructions. Use the scale, you use the normalize and the scale, okay? Now, this is to get the information out. Use scale and then norm to get the information in. To get it out, you use norm and then scale to get it out. All right? So this right here no, I'm sorry. Use Norman and scale from both of them. I'm sorry. This is not right. You use this on both of them. Now what this does is it takes in a value from a min to a max value and outputs in a number from 0 to 1. So norm you put in a number from 0 to some maximum value, and the output value is a number from 0 to 1. Then the scale takes the norm number, the number from 0 to 1, and it puts it out to a value from 0 to maximum. Okay? So what you've done is you've squished it down to a value from 0 to 1, and then you basically bring it back to a number from 0 to whatever your output is. All right? Now, the min does not have to be 0. The min can be the min can be non-zero. This number right here can be, it's the minimum value. It doesn't have to be 0. All right? From min to max to a number from 0 to 1. Then from 0 to 1 to 0 to max. Okay? So that's how that's done, and it's 2 instructions, and it's per analog point. So every analog point that you do, you have to do this to get it in, and you have to do it again to get it out. Allen Bradley, on the other hand, does it very, 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 very differently. They do it inside the configuration of the card. So here is the configuration of the card, and here is the min and the max value. So here would be the name of the point in your program. Okay? And here would be the min and the max value. And then you would proportionate, you would say, which one of these do you want it in what data format? And it would give you, and once you click on this, it would give you a min and a max value for each of the points. So they solve it in a table format as you're configuring the card. This isn't the best description of that. And as a matter of fact, it's one of the limitations of the compact logics processor, okay? So in the compact logics processor, they limit you in some areas, and this is one of the areas they limit you in. In the control logics processor, it's more defined in this area. Even though you can get to it and you can do it here, it's more expansive in the control logics side. Why do they do that? They want you to buy this guy. This is where the big bucks are. The bigger bucks, not the... By the way, where do they make their money in program controllers? Where does Siemens and Allen Bradley, where do they make their money? They don't make a lot on the PLC, all right? And if it is in the PLC, it's on the I/O. The processors are basically given to you at cost. And where do they make their real money? All the other equipment that they sell you. They do not make a lot of money at all on the PLC. But it is the drag, it's what they call the pull-through. This is the thing that once you've got the salesman there and he sold you the I/O and he sold you the PLC, what else you need? Well, I need these motors. I need these starters. I need this motor control center. I need all this other stuff. I need. And that's where they make their money. They make it on the motors. They make it on the other stuff in the system. The sensors, the push buttons, all the other things that you're going to buy from them is where they make their money. They do not make the money on the PLC. Why? Because it's kind of like when you go to the grocery store, the milk is the thing that they price at or below cost. But what happens? The milk is the thing that gets you in. So this is kind of like the gallon of milk, okay? And everything else is what then brings in their money and they make money at. But the milk is what you go for, right? Because it's $2.29. It probably cost them $3 to put it in that case for you. I don't know exactly. I'm not a grocer, but I've heard that that's what the case is, that it's a loss leader, and that's why they put it at the back of the grocery store. You got to walk all the way through the grocery store to the very back of the grocery store to get the milk. Why? Because you have to walk by everything else to get there. All right? This is the same thing. But anyway, they make it easier with the big boy to do this configuration than they do with the little guy. But that's all we bought is the little guy. We bought the compact logics, not the control logics processor. Now, how is that equivalent to Siemens? Well, the Siemens 1200 is the little boy. The 1500 is the big boy. And if you've not seen a 1500, look at the processors that are on the bottom of those. In 1100, when you walk in, to your left, there's that machine there sitting there. Look down at the bottom. All those things in there are 1500s. Go in the back, and the same thing, the machine that's in the back that has the little factory thing, look in the bottom. Those are 1500s. Okay? Those are the big boys. And the same thing with Allen Bradley. The compact logics is the little boy. The control logics is the bigger boy. And they do the same thing. They have little guy, big guy. What do they hope you do? they hope that you buy only the big boys because they make them a little bit more money. The IO especially makes them more money. But what do you compare? You compare the cost. If you're going to make a choice between Allen Bradley and Siemens, other than the fact that your plant is all Allen Bradley or it's all Siemens, what are you going to look for? You look at the price of the basic of the controller, right? That's what you look at. And if theirs is bigger, better than the other guy, and it costs less, that's what you're going to buy. But that's not where they make their money. They make their money on the IO. Okay. A story in economics. It's the truth. That's how it's done. Okay, what else in this chapter? What else did I mention in this chapter that has haunted you from chapter after you read it 3 times? What is it in this chapter that you still wonder about? I'm kidding you. If you read it 3 times, you probably did better than I have. Okay, but how do you wrap your arms around some of this stuff? Okay, what is this? SCCR, what does that stand for? When you walk up to a panel in a control environment, what are you supposed to do? Supposed to open the door? What's the first thing you should do? Can you open the door of a panel? Should you open the door of a panel? Not right away. You should look for a little label on the panel that gives you the SCCR of that panel. What does the SCCR of that panel stand for? Any ideas? So how do you know whether you can even walk up and talk and touch a panel or not? You can't. You shouldn't. There should be a line about 6 feet behind the outside of the panel that you should not go closer than that to the panel. Why? You should go up there and you should eyeball to see what the SCCR of that panel is. There's 4 levels of rating for SCCR. Level 1, level 2, level 3, and level 4. All right? What does SCCR stand for? Short circuit current rating of the panel. Short circuit current rating of the panel. If it's 0, you can open it and you can touch and you can work on it and it'll be fine. You can't touch everything right away, but you can at least open the panel and not be certified, and you don't have to have any special clothing on. You don't have to have the beekeeper suit or anything like that. You can just open it and work on it, okay? That means that it's less than 50 volts, okay? Now, that's what SCCR is important for. If it says it's a level 0 panel, you can open it and not worry about it. But if it says 1, 2, 3, or 4, what do you have to do? You have to be dressed appropriately, and you have to be certified. You have to take a certification test that is a test that is published and kept in with your portfolio of who you are and all that stuff in your panel in your company, and that has to be kept active. Once a year you have to recertify. Every year you have to recertify. Okay? So if you're an outsider, how do you do that? Well, I don't know. You have to figure that out as you walk in, but you cannot just open up a panel. All right? Now, what else haunts you? How do I figure the short circuit current rating, right? How do I know what that is? If I didn't know what it was already on that panel, how would I, if I were to build this panel, how would I be able to put that label on the front of the panel, right? That's the other side of the coin. How do you know how to create an SCCR label? That's the other side of the coin. How would you do that? All right. Well, that's what I'm trying to bring up tonight, is that you have opportunities to become the person that actually can do that. All right. Now, I'll show you some ideas and how to approach this without actually being a guru, because I'm not. This is something that is relatively new in industry, and I didn't ask you to view the gory pictures and all that kind of stuff. I didn't ask this class to do that, did I? I didn't ask you to view the hour-long video of people getting killed and all that kind of stuff. No, I saved you from that. Well, it's there. I have a video of a guy lecturing here at the University of Toledo, and his name is Bob Nicholson, and it is in the EET 4450 class. I think that there's the Bob Nicholson video, so you can check it out if you want to, and you can see what he talks about. But basically, it shows you arc flash and electrocutions and all kinds of stuff, and people getting killed, and gore and all that kind of stuff. It doesn't show you physical gore, but it does show you burns, and it does give you some pictures of things that can happen. And you might want to look at it for your own health and safety. You don't have to for this class, but it's there. So that warning is out there. But how do you protect yourself, and how do you go about knowing how to find what the short circuit current rating of a panel is? Well, I went back this year because I had to, because the other person that taught the course was gone on a sabbatical, so I had to go back and teach that course for them. And I had to go back, and I did, and I'll be a little sarcastic tonight. If you haven't figured that out yet, my sarcasm is on display tonight. But 4350 is the course that I was teaching when I got into all this stuff. And I was, honestly, I thought this other teacher should just be teaching this stuff, and I didn't have to do it, and I was out of that. I could teach PLCs and robotics and all that kind of stuff, and I'd have to go back to all this other stuff. But daggone it, she left for the semester, she left for the year, and I had to kind of hoof it on my own. So this is a supplemental text under EET 4350. So if you want to know where this stuff is, it's in this greater compilation of copy-paste that I did to actually teach this course this semester. And I fought this, but basically I wrote a book as I was going through this. So under this 4350 course, this is called supplemental text, you can go down through here and you can find, let's just download it. And so let's get it now. Let's do this. Okay, so here it is. This is this text in 4350. It says supplemental text. So let's search for, okay, Ted, let's find the SECR. So all tools, organize. Okay, I want to find, how do I find SECR? Find, edit. Okay, I want to, tools, edit. Find. Okay, let's try SECR. All right, and it takes me to some videos under Busman. Okay, so if I click on Busman SECR Part 1, Part 2, and Part 3, I find some very, very, very good videos that tells me how to find the short circuit current rating of a panel. And believe it or not, they do it. Okay? So those 3 videos are excellent at telling you how to find the short circuit current rating of a panel. So it unlocks the mystery of how to find the SECR. So any questions about what I just said? I'm not going to tell you how to find the SECR. I'm not good at it, but I'm telling you how to find it. And if you're in a plant and you walk up to a panel and there's no label on it, what are you going to do? What are you going to do? It's an ethical question. If they've not done that, if they've not put the label on the panel, what are you going to do? The first thing to do is to ask them, what is the short circuit current rating of this panel? And if they say it's level 0, what are you going to do? You're going to say, have you verified that? In other words, I want to see some verification. It's level 0. Level 0 is safe. Level 1, 2, 3, and 4 get progressively more unsafe. Level 4, you have to wear what they call a beekeeper suit to open the door, and it has to be full armor. I mean, it's full. It looks just like a beekeeper suit, and I should show you that picture because it is profound. It's in chapter 10. Okay, so down here in chapter 10, we talk about it. We talk about things that can go boom. That's not it. But it's in here, okay? Not there. It's in chapter, it must be in chapter 20. I'm sorry, I think I took it out of chapter 10 and put it in chapter 20. Yeah, because chapter 20 is the more of the more safety than in chapter 10, and I think I took the pictures out and put them in chapter 20. I do not know what I did with them. I had them, but I don't know where they went. May have gone by too fast in chapter 10. Let's go back to chapter 10. I'm sorry that I'm doing this, but I want you to see what the beekeeper suit looks like because it is full body armor. Well, I may have taken them out. I'm sorry. I think I must have taken them out. I did. But believe me, they're not fun. And I've never had to use them myself, but you might have to use them in order to work on a panel hot. So if the panel is turned off, you can open the door. If it's off, if it's guaranteed to not have any power on it, you can open the door. But if the panel is hot, on, and you open the door and you do not have the proper attire on, you could be, well, some companies actually do not pay your health insurance if you're not properly attired. In other words, if you go up to a panel and it says level 2 and you don't have level 2 protection and you open it and you get hurt, you do not get hospitalization from the company. You have to be, by definition, properly attired or they will not pay you. Okay? Level 4, it looks like a beekeeper. Take my word for it. I can't find the picture. I don't know where it went, but on the other hand, it is a very bad way to have to work on panels. How do you deal with that if it's 90 degrees in the shade? You have to have an air conditioner forcing air into this suit in order to keep you so that you can actually do work. Because if you get hot, extremely hot, you start sweating, your usefulness goes down in a hurry. So you have to be air conditioned, have an air conditioner packed going to your suit in order to work on it. Okay? So it's a very harsh environment, but it protects you. But that's the level that you have to worry about is level 1, 2, 3, or 4. And they tell you on the panel what level it is. So the short circuit current rating can be as high as 65,000 amps. All right? And in that higher range, I don't remember what the ranges are, but maybe 30 to 65,000 or whatever is level 4. I don't remember exactly, but it's how many amps if you have a short from that panel to ground, anywhere in that panel, what would be the current coming into the panel? What would be the the current coming in? And it's simple. It's what? What is I? It's V over R. If R is 0, I goes through the roof. And it can go through the roof. And it can go, in a lot of applications, a control panel can carry 65,000 amps of current. So you can open a panel that can spray copper on you based on the fact that 65,000 amps coming through that panel can actually basically melt copper bar or anything in that panel. And it can spray on you and it will kill you, all right? Definitely mess you up. So SCCR, short circuit current rating, sticker on the panel. It has to be like a label on the panel. You have to be able to see that or else you should not open the panel. Now, if the question that I asked you earlier, what do you do if there is no sticker on the panel or the people ignore it? What are you going to do? It's an ethical question that you have to solve. Do you want to work for a company that ignores the law, or are you going to only work for companies that adhere to the law? Now, this has happened in the last 20 years. In 2010, I was doing the last job that I was working on in industry, and they had little stickers at that time that said high power or danger, it said danger electrical power. That's all it said. It didn't say anything about what the current rating was or anything like that. And I said, these are 110 volt panels. There's no reason to have any stickers on these because they're just 110 volts. And I was going on taking these little stickers off. I didn't know, but at that time that sticker was legal. That worked at that time. In 2013, the law changed again, and at that point in time, they locked it down. NFPA 79 basically said you have to have the sticker on the panel that gives you the short circuit current rating, and it is by level, and you have to know what that level is, or else you can't open the panel. And in 2013, those laws came into effect. NFPA 79E, if you want to know what the exact law is. NFPA, National Fire Prevention Administration, NFPA 79E. Okay? So you open a panel, and if you get killed, basically so sad. But it is not something that you want to ever happen. So again, I don't want to belabor this, but I've given you the tool tonight. It's in this other course, it's 4350 course, and it's down buried in that book, in that course, but it shows you exactly where to go to find how to calculate the short circuit current rating of a panel. And from that point, you can work your way through, and you can actually say, this is what it is, this is what I have to do. Now, the other part of this is that they do not want a low SCCR, they want a high one. They want it at 65,000 volt, or 65,000 amps. They want it high, and why I do not know, but they want it at that higher rating, because they want to be able to protect to the higher rating. But all that aside, those 3 videos from Bussmann will give you all the steps you need to know in order to be able to calculate the SCCR of a panel and to be able to write it actually brings you to the point where you can actually write the sticker that goes on the panel and put that on the panel. So if you ever are stuck with, how do I do this? I'm the only engineer in this company. They basically put me in charge of all this stuff, and I'm doing the PLC stuff, but I don't have a clue about all this other stuff. What do you do? Well, a guy in college, he talked about SCCR. I'll Google SCCR and I find the bus. Oh yeah, it's busman. Oh yeah, I can now look at the stuff and find it out, and it's on those YouTube videos, and you're on your way. But that's where it's at. Okay? I don't want you killed. Is what it boils down to. I want you to be safe, and I want you to have to make logical decisions about this stuff so that you don't get killed, you don't get hurt, you don't charge off into something that you could get hurt in. I want you to be careful. But I also want you to know the ramifications of this. This all happened since 2013. That's not too long ago. That's 13 years ago. That's not that long ago. The laws changed. The rules changed. And if people are back in the 2005 stuff and they haven't done that yet, and they say, we don't apply those rules. We're still in the 2005 stuff. You must ask them, what happens if somebody gets hurt? Who will pay the health insurance? And if they say you're on your own, honest to goodness, I would walk out of there as fast as my feet would take me, because they're not playing by the rules. The rules are based on the NFPA 79 2013 rules, and that's the law. So you must apply those rules or else you're not in compliance. OSHA will shut you down if you have an accident. Worse than that, people could get hurt. And those rules are there to protect you. They're not there to hurt you, they're there to protect you. I don't want you to wear a beekeeper suit unless you have to. But if you have to, I would rather you be in a beekeeper suit with an air pack on than to be fried or to have a spray of a copper hit you and then you be maimed for the rest of your life. I've worked over live copper transformers all night, and the only thing protecting me was a piece of cardboard. All right? Now, if I dropped a screwdriver just right, it could have gone down in there and could have caused a huge mess, including it could have sprayed copper on me. I never let that happen. I was very careful, but if I'd have dropped a screwdriver, it could have happened. You follow what I'm saying? It's not worth it. You should be careful, but more than being careful, you have to now abide by these rules, and I don't want you hurt. So again, I went through and watched the whole series of The Rookie and the Sergeant, the whatever he said. Now be careful out there. So this is my word to you. Be careful out there. All right? It's up to you to be safe. And you're the only person that can be safe for you. And I'm telling you that some of this stuff is not safe unless they've abided by the rules. And if they have, you're very, 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 very safe. Okay? If you have the beekeeper suit on, it ain't going to get you. It ain't. Okay? Any questions? Any comments? This is a different lecture tonight, isn't it? It's a little bit more of a little sarcasm, but whatever. I'm jumping around, and I messed up a little bit with not being able to find the actual picture of a beekeeper suit. I don't know where it went. It's in there, I thought, but maybe not right now. Stuff comes and goes, but anyway. SCCR, it's an important concept. Take care.